Uber is a mobile application that allows you to find nearby drivers that are willing to take you to different places. In this video, I'll be showing you how you can create a Uber clone using Flutter and Supabase. We'll be storing the data in our Supabase database using real-time features and also using PostGIS extension, which allows you to interact with maps in various ways. Note that Uber has two sides of apps, one for consumers and one for drivers. In this video, we'll only cover the consumer-facing app of Uber, but we'll also make a nice script at the end that allows you to simulate a driver's experience, because we also need a driver to experience the full Uber experience from finding a driver to getting onto the car to going to the destination. I've gone ahead and created an empty Flutter project here. Let's start by adding all the dependencies that we need. I'm just going to copy and paste from my cheat sheet outside of my screen. But here's the list of dependencies that we will be needing. Supabase Flutter, obviously, to access our Supabase instance. Google Maps Flutter to access Google Maps. Geolocator to access the GPS information. Duration package actually allows us to parse the specific duration format that the Google Maps API provides us. I'll explain this in more details later. And then info package to, in this particular case, we'll be using it to display currencies in a nice format. We can hit save and install the dependencies. And we also need some assets, so let's add that. For assets, I'll be creating an assets folder, so we can add assets like that. Okay, and then I'm going to add the image assets. I'm just going to copy and paste it. Here's the image assets that we need. We'll be using in this app. So we have a car icon. With the dark background, it's kind of hard to see, but it's a black car with white windows. And again, with the dark background, it's kind of hard to see, but this is a ping. We have two different versions of ping. One where the bottom of the ping is actually at the center of the image, and one where the pin is kind of zoomed in to fill the entire image. We'll be using both. Center pin for when we actually choose a location within the initial screen, and then the actual ping to be used as a ping within the Google Maps. So now that we've added all the assets, let's actually try to display a Google Map in our Flutter app. And in order to add Google Maps, we actually need to follow the instructions on the Google Maps README, because we haven't done all the setup process that are required to set up Google Maps. Okay, so for Android, you can follow the instructions here. For simplicity, I'm just gonna be working on iOS devices here today, so I'm just gonna do the iOS setup, but all the instructions are there in the README file. Basically, you need to open the runner/app-delegate.swift file and add your Google Map API key right there. So let's go to iOS runner app-delegate.swift, and we can copy this piece of code right here, paste it in there. And we also need to copy this Google Maps import at the top. Great, now I just need to go get the API key. Okay, and I can copy and paste my API key right here. We should be able to display a Google Map in our application. So we can delete this center widget here and add a Google Maps widget. Initial position, we can just have a static value, camera position of target, lat, long, just a random position that I have handy here. I think it's the Google headquarter. Negative 4194. Oh yep, that's the longitude. Zoom of 14. And we should be able to display a Google Map with this. Let's take a look. Okay, so I've got a iOS simulator. We should be able to take a look. Or not, because... Okay, so we weren't able to run it because we need to bump the minimal deployment target. So let's do that. We can go into iOS runner, pod file, and just remove this comment out and hit save. And we should be able to run it. Let's run pub.get just in case. And so we got Google Maps showing up, which is great, but we have a lot to do in terms of implementation. So we need to first get a UI so that users can enter the destination. And then we need to be able to calculate the route to get to the user's position to the destination and display that, because it's kind of nice to display all the route on this map. It kind of looks at professional, Uber-like. I guess we can start from there and think about all the other steps from there on. We need to come up with a way for getting the path from point A to point B, and for that we're going to be using the Google's Routes API. The Routes API from Google allows us to pass a origin and the destination. It'll provide a path from the origin to the destination, as long as a few other information such as how long it should take and stuff like that. And we'll be using that information as well to calculate the rough estimate of the fare of our Uber ride. It's not so secure to call these APIs directly from your Flutter app, because the API key is basically exposed to the client in that case, and a malicious user can abuse that API basically. So in order to call this API, we're going to be using Supabase edge functions. So let's set up our edge functions. Within our project, open terminal, and we can call Supabase init. And this is going to set up all the necessary setup for getting started with Supabase project. So now we should have a Supabase directory right here. At the moment it's kind of empty, but we can call Supabase functions new routes. This creates a new edge function right here under our functions directory. So we'll be calling the Routes API from this function. So first, let's get rid of this console log because we won't be needing it. And I guess we can get rid of all the initial boilerplate that we have. Let's keep that response. And then we can first get the parameters that we'll be getting from this request. So basically the way it works is we're gonna be sending the origin and the destination to this edge functions. And then this edge function is going to call the Routes API for us. And we'll get back the routes, and we'll handle the routes on the Flutter side of things. But so first we need the origin and the destination. We can get them like so. Origin, destination. And these will be of type origin. I guess we can call them coordinates. Basically just a pair of latitude and longitude. Destination coordinates. We'll create the coordinates type in a second here, but we can get this from request.json. Let's create the coordinates type just up here. Type coordinates equals latitude, number, and longitude, also number. Great, so we got our origin and destination. Now from here on it's pretty simple. It's basically just calling the Google's Routes API. So we can get a response from a fetch request. And I can go get the Routes API's URL, which is this. You can find this in the documentation. This also takes a key parameter, which we'll need to pass in the Google Routes API, Google Routes API's API key. For this, we can use the environment variable that we'll set in a second. Google Maps API key. Okay, great. Now this will be a post request. So method will be post. And we also need to pass in some headers. The content type would be application JSON, pretty standard. We also need a specific header for the routes API. Basically, it's passing in all the data that we would like to retrieve from the routes API, like durations, routes, distance, why not, just a few information about the routes. And then the body, we can JSON stringify this, construct a object right here. First, origin, and we can't really just pass the origin. There's a specific format that this API requires us, and that's location, lat long, origin, and destination is the same. Location, lat long, destination. Great. A few other parameters. Travel mode, and we can pass drive because we want the drivers to be driving instead of taking trains or other modes of transportation. And lastly, polyline encoding. This tells Google Routes API what kind of geoencoding we want it to use, and we want JSON line string. You can go find different options for these parameters on the official documentations, but for this example, we'll be using these sets of parameters. And that's kinda it. Now that we've made a post request, we can get the data. We can check if the request response is okay, I guess. Okay. And if it's not okay, let's get the error. And console error. And for this example, I'm just being lazy and we'll be throwing a error. HTTP error occurred. I think that's good enough. If you want to do more proper error handling, go ahead and do that. But I'm just gonna assume that at this point we got the data, which is await response JSON. And the structure of this return data looks something like this, where we have a route, which is an array, which contains a legs, which is also an array, and within legs there's multiple steps, which each has, it's not included here, but all the coordinates for this particular route. So in this example, I'm just going to return a response, which is data routes, basically the first route that we get, and we can just pass the response back to the application. And this should be good. Now let's set the environment variable here. So in order to do that, we can create a .env file right here under the Supabase directory. And here we can pass the variable name, which is Google Maps API key. And then I'm just going to copy the API key that I got from GCP console. You can obtain an API key from your GCP console as well. Great. Now that we've done that, we can actually do a few different things. So we've come this far, but we haven't created our Supabase project yet, so we cannot deploy the function. So let's create a Supabase instance. We can head to database.new and create a new project. Uber clone. Database password, we can just generate a password, and we'll be using this password shortly, so let's copy it. And for the region, I'm just gonna choose Japan just because I live in Japan and that's the closest, but just feel free to pick a region that's close from where you live or where your users are, and hit create. Now in a minute or two, this project should be up and running. And there you go, our project is ready. So let's connect our local Supabase project to the remote Supabase instance. We can connect our Supabase instance by calling Supabase link and then passing a project ref and passing the project ref right here. And it's going to ask for the database password. So hopefully you got it. But you can just paste it, hit enter, and we are connected. So now if I hit Supabase functions deploy, it should deploy the function to our Supabase instance. But I also forgot to set the environment variable, so we need to run Supabase secrets set env file, and the path would be supabase.env. Okay, so our Google Maps API key should be set. Let's deploy the functions again. And our functions should be deployed right now. Let's see if we can run the functions. So if we scroll all the way down here, we can find this curl command to run the function. Just copy this, paste it in there. And I also need to pass in some data. So for origin, destination, latitude, longitude. Okay, this should be good. Okay, there you go. So here's what we get. We get legs, and within legs we have polyline, and then GeoJSON string, coordinates, bunch of coordinates, and array. This looks good. So basically we can take these information and display these basically paths to the user within our Flutter applications. I think our edge function is good to go. So we can close that and get back to writing some Flutter code. Okay, so we can start by defining the different states that this app can hold. So there's gonna be 5 steps or 5 states of this app. We can create a enum called app state. And the 5 states will be choosing location. So basically choosing the destination that the user wants to go to. Confirm fare. So once they choose a location, it's gonna display a fare, estimated fare, and asks the user to confirm the fare. And once the user confirms the fare, we will be matching the user with a driver. So the user will be waiting for pickup. And then once the driver has picked up the user, the driver that doesn't exist in this sample app that we're creating will update the state to writing. I couldn't really come up with something clever, but yeah, basically the customer is writing with the driver to the destination. And then once everything's done, we can just call that post write. Basically, after they finish write, the app will show a thank you message to the user, and that's gonna it. So we have these 5 different states. Let's start from implementing the choosing location state. For that, we need to find the user's location, and we haven't actually requested the permission. And we need to, I believe there's some setups that's required to get the user's location. It's right here. So let's complete this step. We can copy this piece of code from the README of Geolocator plugin. And we're probably gonna have to relaunch that, so close the simulator for right now and head over to iOS runner info.plist and paste it right here at the end. Fix the indentation. I think the string is good by default. So now that we have that out of the way, let's relaunch the app. And we can ask for the user's permission. So we can make the app a stateful widget. And then within our stateful widget, we can create an init state. And let's also create a dispose method because I'm sure we'll be needing that as well. So within init state, we'll be doing a few different things. We'll be requesting a permission. We'll be also signing in the user anonymously. That's something I wanted to do. Let's start from requesting the permission. We can call it check location permission function. We can create it down here. It'll be a future void of this function name, no parameters. Let's first check if the service is enabled. Is service enabled? So this checks if the GPS service is enabled. Geolocator dot is location service enabled. And if the service is not enabled, then there's not much we can do other than asking the user to enable it. So mounted shows of context show snack bar, and within this snack bar we can display a text saying please enable GPS. And in an actual code, we might want to do some more stuff. We're just gonna assume that users have enabled GPS and move on. Final permission equals geolocator dot check permission. And again, here we will be checking for a few different things. So if permission equals location permission missing, denied, then let's request the permission to the user again. So we can request a permission to the user, and this should be a variable. And I should have awaited this call. Okay, great. So we can request it, and if the user still denies it, so location permission denied, then we are going to basically do the same thing up here. Show a snack bar saying, hey, please enable GPS. Good. Now once the user has enabled GPS, also there's a case where user has disabled, denied the permission forever. In that case, there's really not much we can do about it. We're just gonna say, hey, please enable GPS, otherwise you wouldn't be able to use this app. And then here we can finally get the current location. So in order to get the location, we can get the position equals await geolocator dot get current position. And we can also store these positions in a local state so that we can actually zoom into the user's location and do things like that. Let's create a variable to hold the user's location all the way up here. So this will be current location of type lat long. I guess we can make it nullable. Also, we can create a camera position of initial position. Now this initial position we can set within this set state. So current location is lat long, and passing the position dot latitude and position dot longitude. And for the initial position, we can construct a camera position. The target should be current location. We know we have a current location. And the zoom level, I'm just gonna put 14 because that's a pretty good zoom number to start with. Okay, now that we've obtained the locations and set the state, let's move our Google Map to zoom into that particular location with this initial position. And for that, we're gonna need a map controller. So let's construct a map controller. Let's create a variable up here as well. Google Map controller of map controller. Okay, so we can take this map controller and go to the Google Maps widget. Within this Google Map, we have onMapCreated callback, which contains a controller. And we can get rid of this const. And the maps controller will be set to this controller. So with this controller, we can basically edit the camera position. Map controller.animate camera, and then we can pass in the camera update.new camera position, and the camera position would be the initial position. And we know that initial position does exist, so we can just add a exclamation mark. And at that point, the whole flow of requesting the permission to the user and actually zooming into the initial position should be complete. Let's try to restart the app. Okay, the user has asked for the permission. Let's grant it. And there we go. We are in there. And the reason why the user location, the blue dot, is not showing up is because we haven't enabled it on our Google Maps widget. So it is my location enabled and true. Okay, so you see the blue dot right here in the middle. Great. So now that user has granted permissions and the map is shown and everything, let's get into creating the choosing location feature basically. So we can create a app state variable right here. So app state, and then we can call it, I guess, app state. Initial app state is always going to be choosing location. So what we need to do is we need to create a overlay on top of Google Maps so that users can move the Google Maps around and set a pin. What we are going to do is we are going to wrap this with a stack. So wrap it with column, change that to stack, and then under Google Map widget, we are going to have a conditional widget. So if the app state is equal to app state dot choosing location, then we are going to display a ping in the center. So child of image dot asset, and the image is stored at assets slash images slash center pin dot ping. Let's display that. Okay, so it's a bit big, so let's set the width to 100, height to 100 as well, see if that's a good size. And I think that's a pretty good size the users can see it. And as you can see, they can move around the ping as they wander around. Okay, so great. Now the user needs to be able to confirm the location, so let's add a floating action button. So floating action button is going to be a floating action button extended. On press, let's worry about that later. And label, we can say confirm destination. We need to make that a text widget. Okay. So we have a floating action button. Let's also make the floating action button center floating action button center float. Okay, great. So basically the user can move the ping and then press confirm destination, and that should set the pin right there and create a nice path being drawn on the map. So within this onPress, we are going to call the Supabase edge functions and first get the path from this from the user's location to this destination. So in order to do that, let's set up Supabase first. So setting up Supabase is very easy. You just make the main function async and then call Supabase initialize. Okay. There needs to be a URL and a anon key. So let's get that from our Supabase project. We can head over to project settings, API, and get the URL. It's right there. And the anon key. Paste it right in there. Now these credentials are safe to be exposed on the client because we can protect our tables using this thing called row level security, where basically we define a condition at which what row can be accessed by what user. So now that we've connected Supabase, we can go down here and keep making this function. So what this function does is it takes the current location and it takes the destination and sends a request to that edge functions that we created. Now we have the user's current location, but we don't have the destination. So what we can do is we can go to Google Map and within the Google Map widget, there is a on map or on camera move callback. So this callback contains a position if the app state is app state dot choosing location. We want to store the destination, and we don't have the destination as a variable yet. So just below current location, let's add it. So lat long of selected destination, lat long. Okay, good. And within this callback, we can say selected destination equals the position of target. Great. So with this, we have the destination and we also have the user's position, which is the current location. So we should be able to call our function. Let's do that. We can say final response equals await Supabase. I guess we don't have a Supabase variable. This is a quick and dirty thing, but I like to have a Supabase variable right here, Supabase instance.client, so that I can access all the Supabase method, which is accessing the Supabase variable. So Supabase.functions.invoke, and we want to invoke the routes function. So we'll be passing a body to that. So the body will contain origin and a destination. The origin will have latitude of current location dot latitude. We can say that we know that current location is available. We have it. Longitude as well. Current location dot longitude. And say that we know for sure that exists. We can copy this over to destination. Change current location to selected destination. And that should be good. This should be calling the function. Let's see if we can get the response properly. Response.data. Okay. So let's test it out. See if we can get anything in our debug console. So let's restart. Move the map and say we want to go here. Okay, so we are getting all the coordinates that constructs this path. That's good. Now we just have to draw them on the map. So we can delete that. Now we can get the data, which is response.data, and this is going to be a map of string of dynamic. And then, so we'll be creating a coordinates variable, and this will be data of legs, the first leg, and polyline, GeoJSON line string. I got this by basically trial and error, just calling the API, see the shapes that it returns, and adjust my code. So duration equals data duration. This is another piece of data that it returns, and it's basically telling how long the entire trip takes us. We can use this duration to calculate a estimated fare of the entire trip. Taking the coordinates, we can convert them to list of latitude and longitude. We can call them polyline coordinates. This will be coordinates.map. So is we can set this as list of dynamic. Then map, and then coordinate to list. Okay, good. Inside here we are going to return a lat long of coordinate of 1 and coordinate of 0. So basically it's going to return a bunch of things, and at the end it's going to return an array with 2 elements. The first one is going to be the longitude, the x coordinate, and the second one is going to be the latitude, the y coordinate. That's always confusing because we always say latitude and longitude, but the latitude is the y coordinate and longitude is the x coordinate. So we have to sometimes do these swaps where we take the first element, second element first, and then first element later. But anyway, this should give us the nice line. Now at this point, we just need to add this path to Google Map, which we can do so by calling setState, and we should have a polyline added to Google Map. The way we can add this to Google Map is we can have another state called polyline, set of polylines. And this is going to be, we can actually declare it as finals. Now we can pass this polyline to Google Maps. So not polygons, polylines is equal to polylines, and then we can dynamically update this polyline. Here we can call polylines add, and then we can construct the polyline here. So we can create a polyline. For the ID, we can just call it route so that we can update it or delete it as needed. Points would be the polyline coordinates. Great. And the ID should be polyline ID of route. Okay, great. Color, we can make it black, just because the actual Uber app is black. And then width, I'm just gonna go with 5. Okay, great. Now, some other edits that we can do, we can also set a marker or ping at the destination. So we can, again, similar to the polyline, we can create a set of markers, final set of marker, and this will be markers, same thing. Set of markers. Okay, and we can pass that to Google Maps. Markers will be markers. Great. And then within after set state, we can create a marker of the pin icon. Here we can call markers add, and then we can construct a marker. Marker ID would be marker ID of destination. Great. What else does this marker need? This marker needs a position, and we can get rid of this const. This marker needs a position, which will be the selected destination. And the icon of the marker, we can have the default icon, or we can get fancy and use a custom icon, which is what I'm going to be doing. So let's create a pin icon, and the reason why we are declaring a variable again is because we need to asynchronously load the icon. Let's create a bitmap descriptor of pin icon. I guess this will be nullable too. And within init state, we can create a load pin icon method, which we can create here. Load pin icon. Now we can set the pin icon equal to a weight of bitmap descriptor dot asset. Now the configuration is going to be image configuration of size I'm just going to say 48 by 48 is enough. And then asset name is just the path to the assets, so assets.images.ping.ping. So now we have asynchronously loaded the pin icon. I'm just going to be lazy, and we know for sure that the pin icon at this point should be loaded already. Okay, so at this point, we should be able to draw the path and display the destination marker. Let's try that. Confirm location, and we get a type error because I'm sure I made a typo somewhere here. Let's see. Oops, yep, I missed one. It's data legs polyline GeoJSON line string coordinates is list of dynamic. Okay, let's give it a try again. Confirm destination, and we have the nice path being drawn on the map. Now at this point, we just need to get rid of this guy right here, which is actually just existing conditionally. So we need to update the state to the next state, which is confirm fair. So we can probably do that. We can update the app state to confirm fair, and it'll be neat if the app automatically zoomed out to the point where all the path is visible to the user. So let's try to implement that as well. So in order to do that, we need to find the bound in which all the path fits. So in order to do that, we can do something like this, where we can declare a bounds variable, which can be lat long bounds. And southwest, we can provide a southwest and northeast to this bound. Now the way we are going to calculate the southwest and northeast of this bound is going to be, so we have the polyline coordinates, and we can map through each coordinates like so, and get the E dot latitude. Now we can reduce it to get the smallest value of all. So if A is smaller than B, then we return A, otherwise we return B. That'll be the latitude. So we can construct a lat long, and we don't need that. This is going to be the latitude, and longitude. So we can edit this to longitude, and we can basically do the same thing here for northeast, except we flip this equality right here to find the bigger values of all. Now that we have the bound, we can call a handy method called animate camera, and then camera update can take a new lat long bound. So we can pass the bounds, and we can pass a padding. I'm just gonna say 100, and let's try it out. So we can move. Obviously my current position is out of my sight, but we get a path, and the camera zooms out so that the entire path kind of fits in. Maybe we can reduce the padding to 50 or so. But I think it looks pretty good. Now let's also update the app state so that we can go to our next state. And we're actually not going to call set state here, but let me just create a method called go to next state. And let's create this method just right here. By the way, I won't be splitting the files in this particular example because I think it's easier to follow me along if I keep everything in a single file. But do let me know in the comments if you like this format, or would you have me rather split different functionality into different files. But okay, so we can call set state within here. So basically, this app state should go into loops where after the last state, the first state comes. So once the user is done writing, in reality, they're probably gonna turn off, kill the app and open the app a few days later or a few hours later when they need it again. But for the sake of this example, after post write, we're gonna go back to choosing location. So it's going to be if app state is app state post write, then app state will be app state dot choosing location, and else app state will be app state values of app state index plus 1. So basically they progress one step, and we can get rid of this final. So now that we have the go to next state, we can call it. I think I've already calling it. So with this code in place, the center ping should disappear once we get the path. Okay, great. So we get the path, we get a nice path being drawn, the center pin is gone. I think we are making progress. So now that user has selected their destination, it's time for them to confirm the fare. So for that, we are going to use a bottom sheet to display the fare of the user. So find the floating action button, and let's create a bottom sheet right here. We can create a bottom sheet, and this is also going to be only conditionally rendered. So let's create a bottom sheet here. We can say if app state equals app state dot confirm fare, then we'll have a bottom sheet. Otherwise, we will have a sized box dot shrink. Okay, so the main bottom sheet here would be a container. The width is media query dot of dot width dot size dot width to take up the entire horizontal available space. And it'll also have some padding of edge insets all of 16 pixels. Okay. Now let's give it some decoration to give it some background color. So color is colors white. And if we want to get fancy, you can add shadows and stuff, but I'm just going to skip that. And child would be a column. So basically in this column, we'll have a whole bunch of texts about this particular trip that user might want to take. And we'll have text of confirm fare. And I guess we can have size box of height of, I guess 16 to give it some gap. And then another text saying estimated fare is, and here's what we need to get. So earlier we got the duration of the entire trip right here. Now what we can do is we can calculate a estimated fare and put it in a variable right here. So a fare is going to be, and we can actually parse this duration to be proper duration type. Parse duration of this duration. This parse duration comes from the duration package that we installed. And actually the only functionality that this duration package serves is this parse duration. But it's kind of nice. Google returns this duration in a format of something like 140s, indicating seconds, and this package is able to parse that. And I haven't checked deeply, but Google might return in other format, and I'm hoping this parse duration package can just handle that. So we can get the duration in seconds or in minutes. Let's get in minutes. Times 40. And let's call C on that so that we can round it up. So duration fare is going to be, the fare variable is going to be the fare in cents, so US cents instead of dollars, because it's more convenient than handling doubles. So we can create a fare late final. We can make it late final because it wouldn't show up before we assign values to it. I guess it can change possibly, so let's make it late. And that's it. We have a calculated fare. Now that we have a fare, we can go back to the bottom sheet. And right here we can basically nicely format the fare. This is going to be number format currency. So we can format a currency nicely. The symbol is going to be a $sign, and the decimal digits is going to be 2, so that it'll always have 2 digits after the decimal point. And what is it complaining about? It's complaining that invalid constant value. Of course, we can get rid of this const up here, and symbol should have a backslash. And then using this, we can format our fare. So, right, we need to restart the simulator. Okay, so now that we have restarted the simulator, we can check the flow so we can confirm destination. And it looks like our bottom sheet is just taking up the entire horizontal space, which we can fix by going to the bottom sheet and make the column main axis size to min. Okay, great. So our floating action button for some reason is not disappearing because we have not made it conditional. This should only appear if the app state is choosing location. So that should, okay, that should get rid of the floating action. Okay, great. Now the bottom sheet is looking okay. We can probably make it look nicer than that, but okay, so let's add some bottom padding. So a trick that I like to do is I chain copy with and call the bottom, and this on this bottom we can add whatever height we have for the safe area. Media query of context dot padding dot bottom. Okay, so this should give it some bottom padding. Now confirm fair. I guess we can make it theme of and get rid of this const text theme large or title large. Okay, good. We can also change the cross-axis alignment so that it'll be aligned to left, and I guess estimate fair, that's fine. 160, we probably need to divide this by 100 to get it converted to dollars. And then lastly, we can add a button to confirm the fare. Elevated button, unpressed tile can be confirm fare. Okay. Now we can fill in this onPressed callback. So within this onPressed callback, we're gonna find a driver that's nearby and available and create a ride within our table. So before we dive into this onPressed callback, we haven't set up anything within our Supabase instance. So let's dive in and try to get that sorted out. So we can go back to our Supabase dashboard, and let's start by enabling the PostGIS extension. So we can go to Database, Extension, and find PostGIS. And we can hit the switch to enable the extension. So that enabled the PostGIS extension, which comes with a whole bunch of utility methods and types, data types to work with maps. So now that we have that in place, we can create our tables using the SQL editor. And let me just copy and paste the table that we will be creating. So here's the first table. Let me close the assistant here. We have a drivers table with an ID of UUID. The model represents the car model, and the number represents the license plate number of the car. And we have this is available Boolean value, which represents whether the driver is available at that moment. And location is a type geography. So this is a unique type that comes with PostGIS extension, and it represents a single point as we have specified here. So basically it's just a pair of latitude and longitude, but it converts that simple latitude and longitude pair into a special format that allows Postgres to set index on it. And then we have a human readable latitude and longitude generated column here. So basically we take the location and we convert it into just a simple latitude and longitude, the double format that we all know. So when we set up real-time listeners, this location is going to be a bunch of gibberish that we wouldn't be able to handle it, but we have the latitude and longitude as a human readable format that we can use to set a pin on it or stuff like that. So we have the drivers table. Let's also set the row level security policies for it. So we are enabling row level security for the drivers table, and the policy is pretty simple. The driver's information can be read from anybody, and the drivers themselves can only update themselves. I guess for this particular app, we wouldn't be using this row level security policy because we wouldn't be working on the driver's side of the app, but it's always good to have them. Let's also enable real-time for the drivers table. So this SQL statement adds the drivers table to the Supabase real-time publication, which is basically turning on real-time for that particular table. I guess we can run this to create the drivers table. Great, drivers tables created. Now let's open another query, and we are going to create another table. We'll be creating a rise table. Before we dive into the rise table schema, we have a enum that we are creating. So the enum is called ride status. It has picking up, riding, completed. Basically, it represents the 3 states of a ride. So ride is anytime a user requests a driver and a driver's found, ride is created. And then at first, the driver is coming to pick up the customer. Once the customer is picked up, they are riding together to the destination. I feel like we can come up with some better name, but that's okay for this. But that's okay. And then completed is basically the entire ride is done. The users delivered to their destination and everybody's happy. So in the rise table, we have an ID column again, UUID simple, driver ID to represent the particular driver, and then passenger ID. Here, this passenger ID just references the auth.users table. We are not creating a public.profiles table for this app to make it simple. But on an actual production app, we probably would like to have a separate public.profiles table. And then we have a origin. So basically, this is the origin of the ride and destination of the ride as well. These two are again PostGIS point type. And then we have the fare, the price of the ride, and then status representing the status that we created earlier. Let's also add row level security on this table as well. 2 policies. So the first policy is that the driver and passenger can look at the ride if they are the driver or the passenger. Simple, right? And the second policy is that the driver can update the ride so that they can update the status column. Okay, great. The rides table to the real-time publication. So we want to listen to the status column in real time as the driver updates the status to receive those updates on our application. So let's run this SQL, and we have created the drivers table and the rides table. Let's create another query, and we are going to create a few more functions and triggers and stuff like that. So the first thing we are going to create is a trigger. The first thing we are going to create is a trigger. Here's what it looks like. Basically what it does is it updates the driver status as the ride progresses. So driver has this is available status, right? And when a ride is created with the driver is no longer available. So we can automate updating that status using a trigger. This first function is the trigger function. So it runs whenever a ride is inserted or updated. And it looks at the status of the ride. If it's completed, then it updates the driver to available. And otherwise, it updates the driver to not be available. Basically, they're taken. And here we are setting that trigger to run whenever there was an insert or update on the rides table. So we can run this SQL statement to automatically update the driver status whenever a ride is created. Lastly, we can create this Postgres function to match a driver with a customer. So this is the function that will be called from our Flutter application whenever a user requests a driver. So we can call this find driver method. So it takes these parameters, it returns a table of driver ID and ride ID. So basically just a pair of driver ID and ride ID so that we can use those information on the Flutter app. It declares a variable of driver ID and variable of ride ID. Then it does a select of nearby drivers. This is looking at 3,000 kilometers radius from the origin and looking for an available driver. If there's one, great, we can return that. We can insert a ride and return the ride ID. If there's no available driver, this is going to just return, and then the Flutter app is going to say there was no available driver nearby, please try again later, or something like that. So once we find that driver ID, then we are going to insert into the ride and create a new column into the ride table. And then once everything's done, we are returning the driver ID and the ride ID to the client. So that's good, let's run it. Great, the function's created. Now at this point, our Supabase database is set up, but we need some dummy data for the driver to kind of simulate what we are doing. So let's do that. We can create a new query. Let's insert a nearby driver. Okay, great. The data is successfully inserted. We can confirm, and there you go, we have it. So now let's go back to our Flutter application and let's create what we left off. So what we need to do here is basically we take the fare, we take the origin, destination, throw all of that into the find driver function, and then get the return value and then handle cases where the driver wasn't found, and then in the case the driver was found, then we can proceed to the next state. So let's do it. We can wrap this entire thing with a try-catch bracket and construct a function call. We can call the function using supabase.rpc, and the function is called find driver. The function takes a params. This is going to be a map of origin is going to be, now here's a trick, we can actually write the PostGIS point in human readable format. It goes like this: point longitude, no comma, space, latitude. So in our case, this is going to be, origin is going to be current location exclamation mark dot longitude. Again, because longitude is the x coordinate, that comes first. And then no comma, but just a space, and current location dot latitude. So that's the origin. We can just copy that and create destination. Again, this is going to be selected destination, longitude and latitude. What else do we need? We need the fare. And the fare is going to be just a fare. And this is going to return a list of dynamic. As list of dynamic. Great. Now we can check if the response is empty. And if it's empty, then we can show a snack bar. So scaffold messenger of okay. And we can say something like no driver was found. Please try again later. I think that's good enough. Now, if there was a data, then we can proceed. Okay, so what do we need to do when the driver is found? We need to first listen to the driver's position so that we can track where the driver is coming, you know, if he's nearby or coming to nearby. And then 2, we need to listen to the rise table so that we can listen to the updates, you know, as the driver updates the status to picking up, to riding, to completed. So let's do that. So we can get the driver ID from the response. So the first response, then driver ID. This is the driver ID as a string because it's a UUID. UUID is string in Flutter. and ride ID equals response first and the ride ID as string. Great, now that we have those two information, we can set a real-time listener. So Supabase dot from drivers stream, we need to pass the primary key of the table, which is just ID, and then we can chain a EQ filter where the ID is the driver ID. Now we can listen to no limit, listen to that stream, and do something with that. I guess update the driver position and whatnot. And we also need to set up listeners for the rise as well. So we can listen to rise. Primary key is ID. The ID that we want to listen to is ride ID. And this will be a ride. And update the app status, I guess, depending on how the ride proceeds. So one thing we want to do is we want to take care of canceling these streams when we don't need them anymore. So let's create that variable up here. We can call them stream subscription of a driver subscription and a ride subscription. Now in dispose method we can dispose them. For this particular app it's not gonna matter because we only have one screen, but it's always a good practice to dispose them once we don't need them. Okay, so we got those stream subscriptions going on. Now we can go back and assign the driver subscription and the ride subscription, the value. Okay, great. First, let's create a type that represents the driver. I'm just gonna be lazy and create them up here, but you could probably do that in a separate file. So let's create the driver class, and I'm just gonna copy and paste this because I know it's kind of boring to watch me type all these models. But here it is, driver has an ID, model number is available, and the location in latitude and longitude. So we can obtain these from the latitude and longitude generated column that we created. And similar to that, we can create the ride model as well. So a ride has an ID, driver ID, passenger ID, fare, and status. And the status enum, we can also get that as well. Pretty simple stuff. But with those models, we can create a variable that represents the current driver. So let's create a driver variable. So we can call them driver. And then we are going to assign the driver to driver from JSON of driver dot first. I should have said drivers, but yeah, that's fine. I'm not gonna worry too much about it. So basically we have the JSON and we convert that to driver type and we assign it to the local variable. So this driver variable is going to be used to display the driver data on the screen, such as the model and the number, so that the customer can find the driver. But we also need to update the map. We'll be updating the driver marker quite frequently, so let's create a separate method called update driver marker and pass the driver. So let's create this method, I guess somewhere up here. I think that's good enough. It's going to be a void method that takes a driver. It's going to set state and remove the driver marker from the markers. So remove where marker, and then marker marker ID value is equal to driver. So the first the initial driver marker is removed if it exists, and then we can add the marker. So markers add, and we can construct a new marker here. Marker ID is going to be marker ID of same thing, driver. What else do we need? We need a position, right? So the position of the marker is going to be driver.location. And we don't need a constant here. The icon is going to be a car icon, which we don't have yet. So let's create it. It's pretty much similar to the ping icon that we created as well. So we can probably rename this to load icons. And then we can create a similar variable here for the car icon. And we can pretty much do the same thing. Instead of pin icon, we are going to get the car icon, which is going to be images slash car.ping. I think the size is okay, so let's test it out with that. So now that we have the car icon, let's go back to where we have the error. So we got the car icon. We know that at this point the car icon is hopefully loaded. It loads pretty quick because it's loading from local, and I think that's good. So let's go back, and we have the update driver marker. Since we know that there's a driver, we can just say we know that there's a driver. And then also, as the driver moves, we can update the map. So at this point, we should probably create a adjust map view method, because we'll be calling this method quite often whenever something moves within the map, and we want to make sure everything is being shown within the boundaries. So adjust map view method is good. Let's create this method up here as well. This is going to be void. And let's think about it. When do we need to call this adjust map view? There's two states when the camera is gonna be zoomed in or out into certain targets. So first, when the car is picking the customer up, we want to focus on the car and the customer. So we want to make sure that both of those two targets are fit in. And then after that, as the car is moving towards the destination, we want to focus on the car and the destination. We no longer care about the origin. And the customer is hopefully inside the car at that point. So we want to zoom into the car and the destination. So the car is always on focus. Now the target changes whether it's the origin or the destination. So let's do this. Let's say we create a lat long target parameter, and then we can make sure that the camera always shows the target and the car. So the car is always in focus. And I guess we can make this a name parameter. I think that's better. Let's first find the bounds for these two objects, the car and the target. Final bounds equals lat long bounds, and then same, we need to find the southwest and northeast. So southwest is going to be lat long of, the latitude is going to be whichever is minimum of the driver location latitude, and the target latitude. Now the longitude is going to be driver location longitude, and this is going to be longitude 2. Now what do we have here? Oh yeah, we know that the driver is there. That's good. add the closing parentheses, and we need to import the min method from the math package, and we need to import min. Similar to the southwest, we can just copy and paste it and change these to max, and latitude, longitude, and wrap everything with lat long. Oops. Put these in there, and great. I think we got our boundaries. Now with that, we can just call map controller dot animate camera dot camera update new lat long bounds, and we provide the bounds, the padding. I think 50 was the magic number that we thought it was good, and that's good. That's it. So we have our adjust map view. So every time we want to zoom in or zoom out into a certain target along with the car, we just need to call this method, and we need to provide the target here. The target, so as the driver moves, I guess the target changes. So when the app state is picking up, so app state waiting for pickup. Okay, so as the user is waiting for the pickup, it should focus on the user in the car, so the current location. And then once the user is picked up, the map should focus on the destination, so selected destination. Good. With that, we have a nice working camera that just kind of follows the car and the destination. Why don't we try it out at this point? Let me just refresh the page, and let's see. Move up here and confirm destination. We have a nice path drawn, and then if I press confirm fare, okay, nothing happens because, let's see, we have the driver, adjusted map view, update driver marker. I feel like the driver should at least show up. Oh well, let's call the go to next state. Let's see. So we can move it, and we can confirm destination, found a path, we click confirm fare. Nothing seems to be happening. Let's check out our tables. Let's see if a ride is created. So nothing is created. Right, because, okay, so here's what we did wrong. Okay, I need to have a closing bracket for this if statement right here. So if the response is empty, if the response is empty, if a driver was not found, we show the message, and if it was found, I think we have an extra bracket here. Capture const. Okay, I think that's good. I think it was just a mismatch of brackets. So, scroll, confirm destination, confirm fare. Here you go. Nothing seems to be happening. There is no ride being created. So let's see. So it's not empty. It goes here, it gets the driver ID. I guess we can see if we got any errors. So let's see. Debug console. Refresh everything. Confirm fare. Scaffold messenger widget is not found, meaning that no driver was found. It's trying to display this error message. Okay, so we can deal with that error later, but let's find out why our driver is not being found. The latitude and longitude of these two guys are right here. A latitude and longitude of this driver is right here, which should be fairly close to where our location is. So it probably means that there was no driver available within 3-kilometer radius from the customer. So let's do this. Let's find the location of this person, which is this. So the customer is right here. Let's update our driver's location. So update drivers set location equals point latitude longitude space latitude, the same thing. Okay, so this should bring the car like right there on top of the customer. So let's go back and redo this thing, and let's reconfirm that the driver is available. Okay, so driver is not available, that's probably why. Okay, let's set that to true. And move the scroll. We're good. We got the fare. Let's confirm, and I guess it's still throwing that error, isn't it? So a ride hasn't been created. Let's go back and confirm fare. And Postgres exception. Value in column passenger ID of relation rise violates non-null constraint. Right, this is a nice progress. So we have a foreign key relations from the rise table to the author users table, but currently the user is not signed in into our project here. So let's just do that. Within init state, we can create a future void of sign in if not signed in method, and within this method we can call supabase.auth.signin anonymously. So this signs in a user. We can check if a session exists, so supabase.auth.current session. If it's null, then call this sign-in anonymously method. Yes, we can await it properly. Make this async. And then we can call this within the init state code. This allows the app to sign in the user anonymously when the app opens up. So with that, we should be good, hopefully. But let's... Okay, so anonymous sign in is not enabled yet. Good call. We need to go to the settings, go to authentication, and enable anonymous sign-in, and hit save. Okay, great. Now we should be good. Let's refresh the app. The user signed in anonymously, and let's go here. Looks good. Confirm fare. There you go. We have a nice car showing up at our location. That looks good. Okay, so realistically, the car should be somewhat far away from the user. I suppose there's a chance that the car was right there to begin with. But let's try to move the car a bit. So we can tweak the latitude a bit. Let's see what this does. Okay, so car moved, and I guess the user is up here, so it's still keeping everything within the boundaries, which is great. Let's move them back, and let's tweak the longitude just a tiny bit so that... Okay, great. So that's a nice shift. Now, I guess one thing that'll be kind of nice is right now the car icon is just facing upwards constantly, which is okay, but ideally the car should face the direction that it's moving. And we can actually do that too. We can rotate the car icon right here. So we have this update driver marker, right? And within this update driver marker, we can also calculate the rotation. So every single time a driver moves, there's the previous position and there's the new position. And from that, we can calculate the angle from the previous position to the new position. And then we can just tilt the car accordingly. So let's do this. So we have a double of rotation. We can just assign 0 to as the initial value. And we need the previous position. So let's just create a state for that. Lat long previous driver position, and this should be nullable now, and we can make this private. Now, as the previous driver, okay, so we can take the previous position. If the previous position is not null, then we can calculate the rotation. Here I just Google how to calculate this rotation, and here's what Google came up with. So I'm just gonna trust it and give it a go. So if the previous position is not null, then rotation should be calculate rotation of start and end, which in this case, the start should be previous location exclamation mark, and the new location is the driver's new location. So this will calculate the rotation, and then we can actually provide the rotation directly to the new marker. So now if the car moves towards the left, let's refresh the page just in case, and then now because the driver status should be automatically updated as a new ride is created, we have to go in and change this to true. Now as the driver moves towards the left, the car should be tilted leftwards as well. So now we have the car right there, right? As we go into the SQL editor and change this value to 5, and let's see if I can quickly run it and go to the app screen. Okay, so I guess it didn't work. Let's try it again. Now 86. Okay, it's moving towards left for sure, but it's not rotating the angle. Right, because we are not setting the previous position anywhere. So we can set the previous position once everything's done at the driver's location. Great, let's try it again. So if I move this to 7. Okay, so the driver moved and the car icon showed up. I feel like this destination, for some reason, okay, something is wrong. Something is wrong, and that is because we are going to the next state every single time a driver moves. Okay, so that is what's wrong with this. So what we need to do is, instead of calling the go to next state within the listener of the driver subscription, we just need to do that at the very end. I have no idea why I included that code within the listener, but let's go back to table editor, list of drivers, change this to true, move a bit, confirm destination, there's the path, confirm fare, there's the car. Let's go to the SQL editor to move the car a bit towards the left. And it does rotate and move to the left. Let's try to move it back to the right. And it's kind of neat, isn't it? The car is moving left and right, and it's rotating to the correct angle. So that is awesome. I feel like we are getting pretty close to a full Uber experience, if you can see it. Okay, so once the user has confirmed the fare, the user at this point is waiting for the car to come pick them up, and we should probably display the car model and car number so that the user can find the car. So to do that, let's use a bottom sheet again. So we already have a bottom sheet, and the bottom sheet is displayed if the app state is confirmed fare. Let's make this or app state is app state that writing, no, not writing, waiting for pickup. Okay, great. So we don't obviously need the confirm fare right there. But what we can do is, let's see, we can wrap this entire column content in a array, and we are going to use the spread operator. This is my quick and dirty trick, and we can add if statement to this. So app state is app state dot confirm fare. It'll show the confirm fare. Otherwise, we're going to show a completely different thing. And I know this widget is becoming pretty massive, but we're just gonna keep going. So app state equals app state dot waiting for pickup. Then we are going to show these sets of widgets. Within this column, I think we can show just a bunch of text about this driver. And I'm not gonna bore you with the actual text, but basic information like your driver, the car model, your plate number, and nice message saying something like your driver is on the way, just patiently wait, thank you. And that's kind of it. So UI wise, there's not much going on here. There's no input from the user. The user just sits there and wait for the car to pick them up. I guess in a realistic app, there should be like cancellation or something like that. We're not going to worry about that. We're going to simplify this Uber app for the sake of this demonstration. So we have a nice bottom sheet that displays all the required information. At this point, the user is just waiting for the car to pick them up, and the way we know that the user has been picked up is by listening to the write status. We can create a local variable. Let's just call this write, since it's technically an array, and we can actually have the typed write from the rise. Okay, great. Now, depending on what the write status is, what we're gonna do is we'll change. So if the write.status is equal to write status dot writing, then we will set state and update the app state to be writing as well. So this is when the driver picks up the person and starts writing, and then else if the write.status is equal to write status dot completed. This is when the entire journey is done. Then we can also update the status app status to post write. Okay, not sure if that was a good name, but we're gonna roll with it. And then there's a few things that we need to do. So once everything's done, we can safely cancel the subscription to all the real-time listeners. So what was it? Driver subscription cancel, and write subscription also cancel. So at this point, we can safely cancel the subscriptions. That's really it, isn't it? I guess we can show a nice modal for that, and that's going to be massive. So I'm just going to create a show completed modal and create a separate method again somewhere up here. Future void show completed modal, and we can show a dialog. Context, we can just pass the default context, and then in the build method, we're just gonna go in. Now within the build method, we are going to return a alert dialog because it has a simple UI, even though this is not necessarily an alert. For the title text, we are going to say something like write completed. And then content, think we can just provide additional text saying something like thank you for using our service. We hope to see you again. Sounds great. And then I guess we can have a simple close button. So text button of unpressed and a simple close. So let's get rid of this const and navigator dot of context dot pop. Great. At this point, the app state should be restored to the initial state, which I guess takes a little bit of cleaning up. So let's see. There's a few things that we should be doing. We need to set the app state to app state dot choosing location, which is the initial app state. Selected destination should be null. Driver should be null. What else should be null? The polylines should be cleared, and markers should also be cleared. I think that's good. So at this point, the user waits for the driver comes, pick them up, updates the status, and then takes them to their destination and drops them off, updates the status again to completed, which displays the modal, and I guess that's kind of it. So let's try out the entire flow. This is gonna be a bit boring because the icons are not gonna move, but we have the drivers table. So let's update the is available status to true one last time. And okay, let's move over here. Let's say I want to go right here. Looks good. Let's confirm the fare. And we got a null check operator because the driver is not assigned yet. So let's see. We had to wait for the... Okay, so this is good because there's technically a time lag before until the driver information is retrieved. So we can just add another if statement, and driver is not null. So once the driver information comes through, we can display everything. Otherwise, we're just gonna let them wait. Let's try it out. So we have the drivers table with one available driver, and I've cleared the rides table. So we can scroll, take me here. Okay, looks good, $3.20. Cool, Toyota Corolla, sounds nice. We can go to the rides table, and this is the only ride, so this is the ride that the user is taking. Let's update the status to writing, which, okay, great. So now it's zooming into the car and the target destination. And hopefully the driver actually properly drives the customer to the destination, but we can change the status to completed, which should update the status. But no, I have a error because I screwed up. So I guess this is a material localization not found. Main app widget require material localization to be provided by a localization widget ancestor. What am I missing? Do I not have a material app here? I don't, do I? Main app. Oh god, okay. Simple. I don't know how that happened, but we can just have a material app, and the home widget is the main app. Good enough for right now. Let's try this again. Delete this ride, which is going to, nope, not gonna cause an error. is available is true because we completed the ride. So let's hit refresh just in case. And move, move, move. Take me here. Good. $3.20, the same price. Looks good. Now we can. The driver is saying I found the person. The person is inside the car, riding with me now. Great. The destination is highlighted. Now we've gone to the destination and the customer is dropped off. Completed. Nice, ride completed. Thank you for riding with us and we hope to see you again. Close. And everything is back to normal except, oh yeah, no, everything is working. So now we can choose a location again to go to a destination. Now that was nice that we could verify the entire flow of the app works, but wouldn't it be better if we had a driver simulation where we could actually kind of see the car icon move in action and take us to the destination? So what I've done here is I've asked Claude to output a nice script for us to use. So basically it takes the Supabase URL, Supabase key, Google Map API key, and a ride ID. And then it's gonna manipulate that ride ID to simulate a movement of a car. I'm not gonna go too deep into the script in this video, but I will create another video in the future explaining how I created this script and how I was able to use Claude to use it for a relatively simple task like this. It's really impressive. So, without further ado, let's actually take this guy for a spin. So let's say, okay, so we want to head west, all the way west, have some fun. This looks like a nice corner. Intersection, $4, sure, it's pretty cheap. Confirm fare. Now with this, we should have a ride in our table. Great. We can take this ride ID, paste it right in here, and then we can run the script. We can run the script. Once I hit return, the car is simulated to go to the... Isn't this beautiful? The car is heading towards our customer. And every 1 second, it's progressing a one path towards our customer. Because we are moving path by path, if the path is a straight line, it'll move quick, and then if the path is curving, a curvature is made up with multiple coordinates, so it'll take time. So it's not a perfect simulation, but it gets the job done. So now we've picked up the customer, now the driver is headed towards our destination. And it's slowly making its way to our destination. Isn't this beautiful? The rotation of the car is properly being calculated and being rotated properly, which is awesome. And we're almost there. Straight line. Goes quick. And we are there at the beautiful park, whatever it's called. Sweet! Ride completed. Thanks for riding with us, and we'll see you again later. Pretty nice, right? So, in this video, we covered how to create a Uber clone app using Flutter and Supabase. We used the Supabase database and its real-time feature, as well as some help from the PostGIS extension to handle the map-related stuff. At the end, we ran some nice simulation using some script generated by Claude, which is nice. But if you want to learn what else you can do with Claude, you should check out this video right here. I'll see you around in another Flutter video. Bye!